Hi everyone, my name is Giacomo Draghi, and this is my registration for CSE 2012, 2012, sorry. And I'll present myself with this little bit of camera that's sharing my screen. And today we will be talking and we will be having a little tutorial over some simple Python fundamental functions. And we'll talk about stacks, sets, and binary search trees, which gets shortened as BST. So let's talk over stacks. What are stacks? Essentially, stacks are a list of items you insert with a LIFO logic, which means, and it stands for last in, first out. And you can imagine it, and we will talk about it as cooking something. And we talked about tortillas in this tutorial. You can think that when you cook something and you get ready for it, then you put it on the plate. And as you put stuff in the plate, you want people to get it. And then you want them to take the last one. Reason being, it's hotter. You don't want to serve cold food. And that is the opposite of FIFO, first in, first out, kind of use. And those are really very commonly used logic in logistics, like Amazon and other businesses that have to manage and sort items. They do use this even to determine the value of what they have in storage. But you can also think of it as an undo function. Okay, when you type the word, the last word you typed, when you do undo, it takes out the last word. Okay, so what you do is what you have with Slacks are simple functions like push, pushing to Slack, pushing to stacks. Is done by declaring the stack dot append and the value. So, for example, appending 1 to the tortilla will append tortilla number 1. And as generally a bigger notation as O01. Top, which as the same big O notation, essentially takes out from a stack. So let's say we have a stack of tortillas, tortilla 1, 2, and 3, and then we want to pop some tortillas. Okay, someone comes and takes it from the plate. And we said that it takes the last one we just entered. So we'll take first 3 and then 2. So if I pop twice and then reprint tortillas, I will find just one. Just tortilla number 1, not just one tortilla, okay? Tortilla number 1. Same thing if I was to append then tortilla number 4 and tortilla number 5 and pop one and then append again. You see that when I popped here, what took off was tortilla number 5, which was the last one when I at the moment I decided to pop. And so we can go on, and we have some properties that are part of the stacks, and that is size and empty. And we use that to check the size of the tortillas, and that is done by using the len command. And we can check if the stack is empty just by doing the len equals 0, and if so, it will return that the stack is empty. Okay, we have a little example over here, and this time we'll change the topic as for pizza. And when we look at pizza, we have 8 slices of every pizza. And if there is no pizza at the table, then you want to make one. Okay, make sure that everyone's got a list of pizza. So you add 8 slices, essentially, and every time a pizza slice becomes less than 3, we want to make an extra pizza just to be safe. Okay, so here is a code, and essentially we start by making the first pizza. Then we take slices, and as we take slices, we go on. You see that we check when we take a slice. If the length has become less than 3, then we make a new pizza, adding to the slice. Okay? And there is a little logic to remember the last slices you took, and you see that, well, as we print at the end, we still have some pizza. We didn't take it all. Okay, but it was a really small example, and you can go over it just to see how a pan and pop worked, and checking the length. Okay, there also is a check for emptiness. If when you do the first pizza, if you make the pizza for the first time, then it will append as follows. Else, here is logic that tries to take the last slice and remembers it essentially. Okay, then you can take a look over this small problem we have. It's essentially just about the same as what we actually did with just a little bit of a stretch, okay? And if you ever find a problem or you find yourself not being able to accomplish this, you can even go and check solution. The solution will have what you looked for, okay? And it's a simple example. Go to the home page, we'll go to the second topic, which is sets. And sets, I use to store multiple items in a single variable, okay? Um, it makes great lists of items, and uh, important properties are uh, they are unordered. Sets do not have precise order, unlike lists. These do have orders. They're unchangeable. Okay, so you can update or assert what you just did. And duplicates are not allowed, so you don't need to check for duplicates. That is part of what set is. So you do declare set with those brackets, as you see, and let's look over the few CRUD operations. And as you will see, we have a create, we have read, and we have delete. We have no upsert or update. That is because they're unchangeable. Okay, you can change. If you want to change something, then you can do an update. But what you actually need to do is to read if it already exists, delete it, and create a new one. Okay, and we go over this. Okay, so for example, we declare this set that has apples, banana, and cherry. And what will we do if we want to create a new item inside this set? Then we do add, and then the value we want to add. And the set will check if it already exists. And as you see, it comes out with the four items we chose. What if you want to read? Then it's pretty straightforward. You can just do for x in name of the set, and that will loop through each item in the set. And as we see in this example, we just print banana, cherry, and apple, which are the elements of the set. And we can also read if something is actually in a set. So we can do a check essentially, declaring the word and check if it's in the set. In and as a keyword, and this set, which is the name of the variable we use for the set. And you see, will print true since banana does appear inside the set. And remove, last operation to delete something that is inside the set. That is given pretty easy. You just remove the name of the item you want to remove from the set. Okay. And we have something interesting, which are some interesting properties of the sets, like differences and union. You can use those to compare two sets. For example, we have a set X and a set Y, and they have different elements, and but some are equal. And if we do differences, it will actually return out a set with the list of differences between the set. So we see the banana is different in Y. Okay, it doesn't appear in Y, and also cherry doesn't appear in the Y set, but apple did appear. So it checked what was in X that wasn't in epsilon, and it turned out that banana and cherry were not part of the epsilon set. Union does the same thing. It does compare the two sets, but it returns the as output the combination of two sets. Okay, we have all now a little example. Uh, if we want to use SAT, we could use a real world example. Okay, we can think of a shopping list, for example. Um, you already do that, when you have your roommates and maybe you want to share a shopping list, and it would be wonderful if you use a SAT to do that. That is mainly because we said duplicate values are not allowed. So you make sure banana, for example, do not appear twice, okay? And that is what we want to do. We want to check if an item is already in the list. If it isn't, you add it. If it is, we say it is. Okay, it says do not allow duplicate values. So it actually wouldn't be a problem if we just said, okay, we don't need to do the check, we just insert. Well, better not. It's better to tell items already on the list. If you want to do better, you can add variable so that you can specify, for example, the banana is already on the list. Just making sure. We have also here again a little problem to solve, and it will take you not that long. I mean, it is pretty straightforward and similar to what we just witnessed over there. And again, if you find yourself having any troubles, a solution is displayed where you can work it. And I encourage you not to go to a solution too fast, okay? Strive. If you do that, you will become better programmers. Over here on binary search trees, as you see, we used a little bit of images. Those are taken from actually another guide, which you can go to at the link of this image, and I'll make sure to include that. Um, what are binary search trees? You can think of it as a basic algorithm that you can use, for example, in searching. Okay, search an engine. And why do we use this? Because they have a big notation of log n, which is a pretty good performance. But unfortunately, Python does not have BST integrated. You can use third party to have some of the classes and some of the main functions you probably want as far as BST goes. So we do use Node in Python. Okay, if you don't come in with the third party class, then you need to use nodes. And essentially, what you do is you create BST by creating a parent node, and then you attach a left child and a right child. And this is basically a little BST. And you can even go on, and you have a parent that will have his left child and his right child, but this parent is also left child with this parent. Okay, it becomes more complicated as you go, as the height of the trees increases. And here is how you can declare a tree. Okay, as how you can init this node class. And just a little example, you can also go here, and what do you do if you want to insert something in the BST? Then you want to check. Okay, does already a tree exist? Okay, in this case, for example, we already have 1, 2, 3, we want to insert 4. But actually, 2 is already present, and left child is occupied, and right child is occupied. Then what do? Then we take this parent and give it a child, you know, and we do that by doing something like this, which is an insert. We check if there is insert present and check if is less from what we already have, and then assign it to the right node, to the left node, or to the right node, accordingly to what we have. Also, traveling in BST is actually the most important part of binary search trees. That is because it's all based on what do you do, how do you travel, how do you traverse them. You can do an in order, pre-order, or post-order, which essentially means we make things in order 1, 2, 3, or we pre-order it, so 2, 1, 3. Okay, the logic of how you read it: parent, left, right, or post-order, which is left, right, and parent. Okay, you from the bottom go to the top, from the top go to the bottom, and in order just left to right. Here is some code you can use, and that is essentially our example, okay, of what you can do. And now, as far as solution go, you have this data. I encourage you to try to create with this data uh, your BST and then order it. Read it as post order, as a pre order, and in order. And if you can avoid to use this pre-made code, it will be great. But you can use it, and it is also part of the solution as always. So back to the home. If anything I said isn't clear, or you find yourself struggling, you don't want to go through solution too quickly, you can always contact me at this email. I will be available and try to reach out to you as fast as I can. So that is all from me, and I wish you good luck with the learning fundamentals of Python.